Okay, for Lab 3, we are going to be talking a little more about VLANs and trunking and some other stuff to go along with VLANs. So anyway, if you follow the lab sheet, I say add 3 switches to the network, and then I say add 3 VLANs to the switches. So we'll go to one of the switches. We can do this a couple different ways. We can simply say VLAN 2, VLAN 3, and VLAN 4. So I created the 4 VLANs. So if I do show VLAN, brief, it shows me my 4 VLANs are now there. We look and see the ports in each VLAN. Right now there are no ports in any of the VLANs, so one of the other steps says connect 3 PC each switch, 1 in each VLAN, so that means we need to put the ports in the VLANs. So I'm going to use ports 1, 2, and 3. I'll use 2, 3, and 4. Port 2 for VLAN 2, port 3 for VLAN 3, and port 4 for VLAN 4. So I'll go ahead and go int FA0/2 switch port access VLAN 2. I'm going to go 3, VLAN 3. I'm going to go 4, VLAN 4. So that put those ports in those VLANs as we were directed. So now we see VLAN 2, port 2, VLAN 3, port 3, VLAN 4, port 4. So it said do the same thing on the other switches. So I'll go ahead and go to switch 1. I'll do it differently this time. This time I will simply add the port to the VLAN, and we will see that it creates a VLAN for us. So see there it says VLAN does not create, creating VLAN 2, creating VLAN 3, creating VLAN 4, do show VLAN brief. Now the VLANs exist. Oh, I messed that up. Good thing I looked at that. So I went and put port 2 in VLAN 2, and then I mistakenly didn't change my port number to 3. So I only have port 2 in VLAN 3. So we need to fix that. So we'll go int FA2. We want that in VLAN 2. Then we want FA3 in VLAN 3. And we want FA04 in VLAN 4. So now if we show our VLAN information, now it's correct. So that put the ports in the VLANs as I wanted. So there's 2 ways you can do it. If you're doing a lot of them in the simulator, you can simply copy and paste if you're lazy or efficient. And now we'll delete this one. Get out of here. We'll delete this one. Yes. And we'll move this copy over here. And we will change the name. So for you, it'd probably be good to practice adding the VLANs again, so you could practice that. But just for fun, we'll look at this. So this is the switch we just copied. Show, and we see that our ports are in our VLAN. So now we want to connect 3 PCs to each switch, 1 in each VLAN. So that means we need to do 2 things. 1, we need to put some PCs out here. 2, we need to connect them to the switch. So that'll be my VLAN 2. That's not what I wanted. I wanted to get a cable. So this will be my VLAN 2 PC, so I'll connect it to my VLAN 2 port. This will be my VLAN 3 PC. That's not what I wanted. No, VLAN 3 PC, I'll connect it to my VLAN 3 port. And this will be my VLAN 4 PC, I'll connect it to my VLAN 4 port. So that was that for that switch. We need to do the same thing for the other switches. We also need to go ahead and give IP address information. So as we should hopefully remember from our review we had and our understanding from previous lab activities in classes, machines in the same VLAN need to be in the same subnet, and machines in different VLANs need to be in a different subnet. So I'm going to use 192.168.2 for VLAN 2. I'm going to use 192.168.3 for VLAN 3, and I'm going to use 192.168.4 for VLAN 4. Right now, we only have a switched network. We do not have a router, so we don't necessarily have a gateway. We will not be able to ping between VLANs when we get this set up, but later on in the lab, we're going to have a gateway. So I'm going to go ahead and add the gateway information for what I'm going to make the gateway be. I'm going to make the gateway be 2.1, 3.1, and 4.1. So I'm going to go ahead and add that information now so I do not have to come back to each PC later. So this will be my VLAN 2 PC. Sorry, VLAN 3 PC. And then I'll go ahead and add the gateway, even though, like I said, we don't have a gateway yet. And then my VLAN 4 PC. Alright, so now I need to do the same thing for the other 3 switches. Same thing applies as before. You know, you can copy and then paste, drag these guys over here, and then paste again. Drag these guys over here. Change the names if you want. I don't really care. I'm going to change the IP or add IP addresses since it deleted them out. So I use 2.2 on the other PC. I'll use 2.3 on this switch is PCs. 3.3 and 4.3. And I need to connect them. So this would be VLAN 2, so I go to port 2. This will be VLAN 3, so I go to port 3. And this will be VLAN 4, so I go to port 4. And then over here, same thing. Change the IPs. Two 2.4, 3.4, and 4.4. And then, oop, I didn't want that. What the heck just happened? Undo whatever the heck I just did. Whew. That could have been ugly. And now 4.4, which is still there. Good. Alright, now I need to connect them. Port 2, port 3, and port 4. So I have PCs connected to the ports. If you mouse over, it shows that the interface is up and which VLAN it's in. So now we need to connect the switches together, right? So to connect switches together, what kind of connection do we use? Crossover, right? So we're gonna connect the switches together. I'll use the gig ports for fun because that's probably what you would do in the real world. Because gig's faster than fast Ethernet. Alright, so all my switches are connected together. It's orange right now. It'll be green in a minute. While we're waiting for it to turn green, let's talk about what is going to happen. So we have connected our PCs to our switches. We've connected our switches together with certain switch ports. The switch ports we connected together are VLAN 1 switch ports. That's the native VLAN, that's the default VLAN. So if all of our PCs were in VLAN 1, this would work fine. But since our PCs are not in VLAN 1, we're not going to be able to ping across the switches because the VLAN 2, VLAN 3, and VLAN 4 traffic will not exist in VLAN 1. So for fun, let's go ahead and try to ping 192.168.2.3. 2.3 is this PC down here. So if this was configured correctly, we would expect this to work because the traffic should flow across the link between the switches. It's not working because we have not connected the switches together in a manner that could allow VLAN 2 traffic to communicate. So we could fix this by going to our gig ports. Let's go ahead and do that for fun. Gig 11 and gig 12. Let's go ahead to gig 11 int gig 0//1. Why is it not like that? Let's get out of here. Gigabit. I don't know why they're doing like that. 0/1. 1/1. Is that why it's not liking that? Yeah, 1/1. Let's put this in VLAN 2 for fun. Spell switch right. Switch port access VLAN 2. Alright, let's go over here. And on this switch, it's gig 12. So let's modify that. And put it in VLAN 2. So let's see what we got. Alright, so once this turns green, we'll try our ping again. And what we should see is we should see that the VLAN 2 PCs will work now because those switches are connected together on VLAN 2. But what we're going to see after that is VLAN 3 and VLAN 4 still aren't working. So VLAN 2, please work so I don't look like a fool. Alright, so there we go. Took a minute. I guess maybe spanning tree nonsense wasn't done. So yeah, so VLAN 2 we can now ping because this link is a VLAN 2 link. So let's try out a VLAN 3 PC to verify that it does not work like it's not supposed to work. Ping the space. Alright, so now VLAN 3 is not working for the same reason VLAN 2 did not work a minute ago. There's no connectivity between these two switches on VLAN 3. So how can we fix this? Could we add another link and make it in VLAN 3 and then add another link and make it in VLAN 4? Yeah, we could do that. We could have one link between switches for each VLAN. That's not a very efficient use of your switch ports. So what we will really do is configure trunking. Trunking is a mechanism that allows switches to pass traffic from multiple VLANs across one link. So what we're going to do is go ahead and configure trunking. So switch port mode trunk will enable trunking on this side, and then a command we can run to look at our trunk status is show int trunk, and we will see that gig 11 is on and its status is trunking. So what that tells us is that we should now be able to ping on all the VLANs between these two switches. Oh wait, we're waiting for spanning tree again. So let me go back for a second. If you'll notice, I turned on trunking on this switch, but I did not change anything on the other switch. I did not change anything on switch 1, but it still came up as a trunk. If you recall, we talked about the administrative modes and the operational modes. So the administrative modes are access, dynamic desirable, dynamic auto, and trunking. So when switches are set for trunking, they negotiate with the other switch to see if the other switch wants to trunk. In this case, the default setting is dynamic auto, which means that the switch will not actively initiate a trunk, but if it receives a trunking negotiation, it will allow trunking. So I configured this switch for trunk, which is a setting meaning I want you to be a trunk port. It negotiated with this switch for trunking. This switch's settings were dynamic auto, so it said, sure, I'll be a trunk, and agreed to become a trunk interface. So if we look at show int GI 1/1 switch port, this shows us some settings about our switch port. Administrative mode is trunk, operational mode is trunk. If we look at this other switch, the interface we're connected to on this switch, we'll see that its administrative mode is dynamic auto and its operational mode is trunk because it received a trunking negotiation. If we go look at one of this switches, switch port, one of this switches switch port settings for one of the ports we've connected to the other switch, we will see that it is set to dynamic auto, but its operational mode is static access. What that means is that nobody has sent it a negotiation saying, hey yo, let's become a trunk. So what we're going to do on this switch is we're going to go into that interface and we will change its setting to make it become a trunk. So on the other switch, we set the setting to trunk specifically. On this switch, we're going to set it to dynamic desirable. So dynamic desirable means it's going to try to become a trunk. And if we do our command to look at the settings, if it's assuming it's finished the negotiation, its setting is now dynamic desirable and its operational mode is trunk. So in theory, this link and this link are both trunk links. This is a link in VLAN 1. So at this point, we should be able to ping between all of our PCs on all of our switches. This is a link for redundancy, so I'm going to go ahead and change the settings on that one to make it a trunk too. We'll go ahead and set it to trunk. So in order for a trunk in order for a link to become a trunk, the administrative modes must agree to trunk. So essentially, if you have two modes that will negotiate trunking, it will become a trunk. If either side is set to access, it will not trunk. If both sides are set to dynamic auto, they won't trunk. But if you have one side is trunk and the other side is either the dynamic settings or trunk, it'll become a trunk. If you have one side is dynamic desirable and either of the other sides is a dynamic setting or a trunk, then it'll trunk. So that's the things to check if your trunking is not trunking. An interesting thing about trunking is when you look at the mouse over in here, you'll notice it says Gigabit Ethernet 1/1 up. It does not list the VLAN. It lists dashes there. That shows that that port is configured as a trunk. The command we looked at to see our trunks, which is a very useful command to know, and you will hopefully use it throughout the class. To show in trunk, you can see which ports are trunking, which VLANs are allowed across the trunk, and all that kind of stuff. So that's trunking. Let's go ahead and verify that our PCs can ping what they're supposed to. So 2.3, 2.4. Remember, we will not be able to ping 3. anything at this point because we still do not have a router. Let's go to our PC 3, our VLAN 3 PC. Make sure it works. Yep, 3.3, 3.4. Then we'll go to our VLAN 4 PC and make sure it works. Alright, 4.3, 4.4. Alright, so now we've configured trunking. We've verified that it works. And yeah, so now let's take a minute, step back, and talk about what trunking actually does. Trunking sends traffic across a single link for multiple VLANs. So it does that by identifying which VLAN the traffic needs to go into. And in this particular case, if we do our this command, show interface gigabit 1.1 switch port, we see that our encapsulation is .1Q. Our book talks about two types of encapsulation, .1Q and ISIL interswitch link. ISIL is kind of old and deprecated. Our switches in the lab do not support ISIL, so we won't work with it much. .1Q is a newer standard. ISIL is Cisco proprietary, so it only works on Cisco switches. So ISIL will take the frame and fully encapsulate it inside a new frame, and when the other switch gets it, it will pull it out. So if we were using ISIL, this PC would send a normal Ethernet frame. It would get to this switch would consult its MAC address table and say, oh, I need to send that across this link, and it's a trunk link using ISIL. So I'll put this entire frame inside a new ISIL frame and send it across to this switch. This switch will get that ISIL frame, pull out the original frame, consult its MAC address table, and say, oh, that needs to go out this interface to this PC, so we'll send it out that interface. That's how ISIL works. It fully encapsulates the frame inside another frame. 802.1q adds an 802.1q header to the frame. It essentially tags the frame in a similar manner as ISIL, but it just adds a header inside the frame instead of fully encapsulating the frame. So in this case, if we're using 802.1q, this PC sends a normal Ethernet frame, comes in this switch. This switch consults its MAC address table, says, hey, I need to send that across a trunk that's using 802.1q encapsulation. It will put the 802.1q information inside the frame in the proper location. It will send it to this switch. This switch will get and say, oh, hey, this frame is coming across the trunk. I'll check the VLAN tag. It's tagged for VLAN 2. Let me see which port it needs to go out to arrive at that VLAN 2 MAC address, and it will send it out this port. So that is trunking in a nutshell.